I'm Alexander Sokol from Ukraine, and I want to present you my scientific exploration, which called Earth-neutral pulsed electromagnetic field and seismic activity analysis. From the last explorations, we know that preparation earthquake process in seismic region is an important stage in the seismotectonic exploration of any region, and Earth-neutral pulsed electromagnetic field is an effect of electromagnetic pulse generation by rocks when it deformed, developed by Professor Vorobyov in 15th. Generally, earthquakes trigger high values of this parameter. It's a well-known fact, but it can demonstrate how rocks deform too. Earthquakes have a large ecological role. They can change land ecosystems in many different ways. They can trigger ground rupture, landslides, tsunamis, and liquefactions. These disasters, of course, change the environment. Earthquakes kill 10,000 people on average every year and cause billions and tens of billions of United States dollars in damage. Over time, in some regions, seismicity increases and it can trigger ecological catastrophes. That's why we must search all methods to explore and anticipate seismic activity. Seismologists usually use the deformographs in their explorations for land movement monitoring. But the deformographs are big and expensive machines that need large parameters underground, stable temperature, and recording systems. Our methods are cheaper and portable. For this experiment, we measure electromagnetic emission, number of electromagnetic pulses E and B, EMF in frequency range 12.5 and 17 kHz, 3 times a day, and note measures for tables in notebook. Get data about rocks deformation from the post of deformation monitoring, register earthquakes and take notes, build graphs and analyze it. First graph. Graph of electromagnetic emission in the frequency range 12.5 kHz, blue diagram. Deformation of rocks, red diagram in period January-August 2018. Analyzing it, we can see that quick horizontal movements trigger intensive changes in electromagnetic emission. Especially electromagnetic emission increasing correlate with negative earth crust movements, with compressions. But sometimes we can notice that electromagnetic emission increase without intensive horizontal movements. Vertical land movements, which we cannot explore, can trigger it. Next graph. Graph of electromagnetic emission in the frequency range 17 kHz, blue diagram. Deformation of rocks, green diagram, and seismic state, red spots, earthquakes. Period January 2019. We registered 4 earthquakes in January. Analysis shows that quakes have occurred in 2-4 days after electromagnetic emission, quick increasing 3 quakes or decreasing 1 quake. Electromagnetic emission increase in rock compression period and decrease in expansion period. Next graph in period April 2019. We registered 11 earthquakes. 3 earthquakes have occurred after electromagnetic emission increasing, 5 after electromagnetic emission decreasing, and 3 have occurred when electromagnetic emission values were steadily high. About electromagnetic emission and earth crust movements coincide, we get same result. Next graph. In a period May 2019. 2 earthquakes have occurred after electromagnetic emission increasing when rocks were expanded, and 1 earthquake has occurred after electromagnetic emission decreasing when rocks were compressed. Next graph. Next graph in period August 2019. In August, we registered 4 earthquakes. 3 have occurred after electromagnetic emission decreasing, and 1 after increasing period. Next graph. In period November 2019. Maximums of electromagnetic emission pulses mostly coincide with rock compressions, minimums with expansions. Sometimes our parameters don't coincide with each other. Some factors can distort the results when it has a major effect, especially vertical movements of earth crust, hydrological and astrophysical factors can distort results. In future explorations, we take these factors into account. Seven earthquakes have occurred during the electromagnetic emission decreasing periods after intensive increasing periods. Six have occurred during increasing period after intensive decreasing periods. Two occurred without horizontal crust movements, but in a few days before, we registered electromagnetic emission increasing. Go to the results. We get positive results. Research supports our hypothesis about electromagnetic emission using in seismic explorations. We registered 116 local earthquakes. Electromagnetic emission increase correlates with earth crust compressions and decrease correlates with earth crust expansions. We registered earthquakes in 1-2 days after intensive electromagnetic emission increase, rocks compressions, or intensive electromagnetic emission decrease, rocks expansions. Sometimes earthquakes have occurred without horizontal movements of earth crust, and electromagnetic emission can help us to get information about vertical earth crust movements. We need this information for earthquake anticipate. In future studies, I want to explore alternative energy which we can get from earthquakes or other tectonic energy sources. Thank you for your attention.